In this video, we will run through an example scenario planning out a red teaming activity for a chatbot powered by generative AI that will be used by a fictional medical insurance provider. While planning the activity, we will follow along with the key questions and considerations proposed for doing so in the Red Teaming for Generative AI, Silver Bullet or Security Theater paper authored by Pfeffer, Sinha, Deng, Lipton, and Haydari. Chatbots are becoming integral to customer service in various industries, including medical insurance. But before deploying a Gen AI-powered chatbot, it is crucial to conduct thorough red teaming to uncover potential issues. Red teaming is a simulated attack and assessment process designed to test a system's defenses, functionality, and compliance. Here's how we can effectively red team a chatbot using Mistral AI. The proposed key questions and considerations are grouped together into three phases: the pre-activity phase, the during-activity phase, and the post-activity phase. Let's first take a look at those that should be asked and considered before the activity commences. Prior to beginning to red team the system, the evaluation team will need to identify the details of the AI system, understand the overarching goals of the red teaming activity, highlight any specific vulnerabilities that are of concern, determine the success criteria for the activity, and build the evaluation team that will be performing the activity. Thinking back to our fictional scenario where we have our chatbot built for servicing customers of our medical insurance provider, the developers of this system chose to incorporate European-based Mistral AI. Specifically, the team will need to identify the version of the model being used, which in our case is Mistral Large 2. Open source intelligence research tells our team that there are minimal guardrails in place with this model. We also need to determine which stage in the life cycle of this system we are performing the red teaming activity. In our case, this is prior to the application going live to the customers. Finally, the conditions of release for this model need to be well understood. Here we are working with one that has been open sourced. Next, we need to understand the overarching goals of the red teaming activity. Evaluation teams should have a thorough understanding as to whether they are looking for any and all vulnerabilities in the system, or one or more specific vulnerabilities based on a specific attack method that threat actors have been actively exploiting or could potentially exploit in the future. The impact of the vulnerability being exploited should also be considered. For example, some exploited vulnerabilities could lead to highly sensitive data being exposed, whereas others may only expose much less critical data. In our specific scenario, we want our red team to specifically target vulnerabilities that could lead to personally identifiable information, or PII, data leakage. We have identified PII, data leakage, as an area of focus because the medical insurance company that has contracted the company to establish the team and perform the red teaming activity has had previous exposures of customer data, such as social security numbers and historical records containing medical procedures. The legal team and company executives have established a near-zero tolerance policy for future exposures due to the risk of further lawsuits, bad publicity, and losing more customers. Additional funding has been set aside for red teaming activities for all systems that could potentially expose this data. While a near-zero tolerance policy has been established, the executive team also recognizes that a threat actor would probably give up trying to exploit a vulnerability after some period of time. This is where the threshold of acceptable risk comes into play. Typically, a threat actor is going to move on to other systems if the reward is not worth the amount of time that they have invested into exploiting a system. While sensitive customer data, such as what this system contains, can be used for phishing campaigns and identity theft, spending days at a time trying to exploit it may not be worth the potential payout. In our scenario, we have come to an agreement among all parties that 450 prompts would take over 2 days for someone to attempt, and that we could all accept the risk that threat actors would have moved on to other systems prior to reaching 450 prompts. Next, we need to determine the criteria for assessing the success of the red teaming activity. Since we are looking for a specific vulnerability and specific outcome of retrieving customer data, if the team is able to produce the fictitious customer data already loaded into the system prior to putting it into operation, the team would be successful with the activity. Additionally, one requirement already established within the contract for the activity is that of being able to reproduce the exploit if successful. All prompts will be recorded to ensure that the exploit can be reproduced by the team that has developed the system. Reproducing the exploit will help them with establishing mitigations. The final set of questions that should be considered during the pre-activity involve establishing a team that has the greatest potential of achieving success. In addition to stakeholders within the medical insurance company, considerable thought also needs to be applied to selecting expert red team members. AI/ML prompt engineers, cyber analysts, AI ethicists, and policy experts have all been selected by the company and agreed to by stakeholders within the medical insurance company as well. These diverse roles will allow multiple viewpoints to be considered when establishing the proper prompts for the activity to be successful. Since the company that specializes in red teaming activities is still in startup mode, they unfortunately have not yet found a diverse group of employees to fill the roles. The majority of the engineers, analysts, ethicists, and policy experts are middle-aged Caucasian males. This could introduce a risk by not having substantial, diverse thought across the group. However, with the amount of money and time allocated for this activity, the medical insurance company has agreed to accept this risk. The next phase to be considered is that of during the activity. While the activity is occurring, the red team will need to identify the resources available to the red team, determine the instructions given to participants and level of access, and establish the methods and availability of automated tools for the participants. At the initiation of the red teaming activity, specific agreed upon resources will need to be provided to the red team. Unless the red teaming activity is meant to test for insider threats or current employees with internal level access, access to the system would typically mirror how an adversary would be interacting with the system. In this case, adversary access would likely be from outside of the boundaries of the internal network and coming from somewhere out on the internet. The resource description should also include the agreed upon time bound for the red teaming activity. Since the executives of the medical insurance company agreed to accept the risk that an adversary would probably give up trying to exploit a vulnerability after 2 days of work, the red team will also have 2 days to perform the activity. Next, the red team needs to be provided with instructions to access the system. The instructions would include how to access it and the goals of the activity, which in our case is to pull the fictitious customer data that has been populated into the system. Finally, any other restrictions also need to be provided up front. These can include only allowing the red team to interact with a user interface that customers will be seeing, instead of trying to attack other systems in the network that might allow access to the back-end data. The use of artificial intelligence tools to craft their prompts when interacting with the large language model, and any other restrictions. The final phase to be considered is that of post-activity. When the activity has completed, the red team will need to craft post-activity required reports and documentation, determine whether or not the activity was successful, and recommend mitigations for the vulnerabilities. First, the red team will need to create an evaluation report. In the case of our specific scenario, the information within the report would typically be agreed upon between the contracted evaluation team and the business stakeholder of the medical insurance company prior to the contract for the work being signed. Additionally, the individuals and groups that will receive access to the findings will also need to be pre-established, as the fact that there are vulnerabilities in the system should be treated as sensitive in nature. In our case, with the system not yet operationalized, disclosing that there are vulnerabilities is less of a risk. Ultimately, the business stakeholder will need to present the development team with the above information, along with details of how the vulnerability was exploited and any recommended mitigations to keep the vulnerabilities from being exploited. Next, the entire team will need to determine whether or not the red teaming activity was successful, based on the success criteria established prior to the activity. In our scenario, the red team was able to generate prompts that provided customer data within the first day of testing. Finally, the red team should be able to provide some recommendations towards mitigations for the vulnerabilities that they found. These recommendations could include retraining the model, redeveloping the model, or even compensating controls. In this video, we ran through an example scenario planning out a red teaming activity for a chatbot that will be used by a fictional medical insurance provider. While planning the activity, we followed along with the key questions and considerations proposed for doing so in the Red Teaming for Generative AI, Silver Bullet or Security Theater paper authored by Pfeffer, Sinha, Deng, Lipton, and Haydari.